Hello class, this is Patrick Brooks. Today we're going to be covering the sequel 3. I call it sequel 3. It's actually chapter 3 from the Oracle book and chapter 4, if I'm not mistaken, from the Acris book. We're going to be going over joins, and up to this point I assume that you have already watched the Illuminate PowerPoint presentation and viewed the PowerPoint. If not, you need to stop and do that first. Because here we're just going to be doing a little bit of extra. I'm going to show you, how this works and the idea behind it in SQL. It won't be too long, but it won't be just a 2-minute thing either. So bear with us here. All right, so I guess we'll go right into it. I'm still using MySQL. I guess it's fair. It's neutral. It's kind of a third-party thing, and I like the interface. It's easy to show you the results, and you can see what I'm doing. It's not a true. There's no query wizard here. I'm actually doing everything here in the command window, as you can see. So here, I'll go ahead and connect, and excuse me. We'll go ahead and start here. And the syntax differences are really minor between MySQL and Access and Oracle. There are a few keywords and just a few things to keep in mind, but that's really about it. Okay. So all I did there is tell it the schema to use. I have my database schema down here, test. All right. And I'm going to add some tables to it. All right, so I guess I'll set everything up. I'll tell you what, I'll go ahead and I'll use a database somewhat similar to what we have going on in the book. I was thinking of doing something with students, since that's kind of most applicable, and you'll see the parallels there. I was thinking about doing student and something with the departments, let's say a major department as well. So I guess we'll jump right into it here. I'll go ahead and create the table here. A little painful, but not too bad. So bear with me just a minute. Yeah, let's do 50. All right. Okay, so what I did here, excuse me, let's see if I can maximize. No, apparently I can't, so just bear with me. All right, so I'm creating a table called department. Now it's going to have the following attributes: a department code, okay, which is for a character string of length 4, and it's going to be the primary key. It's a good primary key for department would be a code, and I'm thinking alphanumeric code here. It'll have a name, which is a character string of up to 50. Okay. So we'll say each department has a budget. That's pretty good too. Let's say it's an annual budget. It's numeric, so it can have 10 total. 10 total numbers here with 2 after the decimal point. Excuse me, let me clear my throat. Okay, sorry about that. So we'll go ahead and create it. Okay, I accidentally hit the execute button twice. All right. And now we'll create our student table. Student number will be a good primary key, right? Name. Let's say character string of length 60. That's good enough for these hyphenated names and whatnot people use. We'll make that our primary key for that. And I'll go ahead and add a foreign key. And what did I call that primary key of the department table? I think it was department code. Yeah. All right. So I created a students table here. All right. We got a student number. That's going to be our primary key. That's a pretty good, excuse me, natural key here for this table. All right. They have a name, which is a character string of up to length 60. Okay. They're going to have a GPA, which makes sense as students. They are going to have their major here. It's going to be major code, and that, that's pretty much what you have in the book, in the database that's supplied is department code. I just call it major department code. Same thing. All right, character string of length 4, and I will. Oops. There we go. A little MySQL syntax thing, and I will go ahead and link it to the department table via the department major code. So, you see the department major code, character string of length 4, so it coincides with the same, has the same data type as the primary key of the major, or of the department table. So, foreign key has to be basically the primary key of some other table. And that's a way of relating the two tables. So that's what I have here. I'm relating the student table to the department table through the foreign key major department code. So I'll go ahead and create this, and hopefully we won't get any error. Let's see. I have an error. Major. Give me just a sec. I'm going to troubleshoot here. Actually, I think I just figured it out. Maybe this space here between the keyword E and the actual foreign key. Now let's try it. Yep. There we go. So that was it. So apparently you can have a space there between foreign key and the parentheses. I didn't remember that. All right. So I've created my department, and let's check these out, by the way, just so you kind of get a feel for what we're doing. All right. So here we go. Quick graphical overview of our table. This is one of the reasons I like MySQL here for these lessons. Department code, okay, it's character. Of course, we can't have null because it is our primary key. All right, okay. And we have a name, which is a friendly name. Character string of up to length 50. All right, and then we have a budget. The department annual budget for the department. Okay, and we'll look at the student table as well too. There we go. So I have a student number. It's 9. It's going to be kind of like the security number, 9 digits. Student name, character string of length 60, GPA, which is a floating value. That's a decimal value basically. I could have put numeric 3,2 in there, but I just figured I'd put float. Why not? Just be different. Why be normal, right? All right, we have major department code. That is our foreign key. That's our foreign key to the department table. Okay. All right, now I'll go ahead and start populating these so we can actually work with them. All right, so we'll create some fictitious departments here. Start with computer science. We'll go take. There we go. That's the budget. All right. And with MySQL, I can just go ahead and it'll batch these. So I'll just go ahead and type them all in here. What else? School of Engineering. Gosh, let's go ahead and get artsy. What do you say? And they don't have a big budget. They just like make stuff, right? They don't really do a whole lot in our department. Just kidding. That's an art joke. Biology department. No, you know what? We'll go ahead and make this cool. We'll call it biological sciences. Make it sound really important, right? There we go. Now they're all distinguished. All right. What do you think? Enough departments? Yeah. Go ahead and batch it. Said, go ahead and batch it. There we go. All right. So it inserted the 4 rows. Okay. And I guess we'll go ahead and do the same for the students. We'll set the problem up here so you can see what we're doing. Remember the insert, the syntax, right? Insert into table name, and then in parentheses the values that you're going to insert. They need to match in order. The parameters have to match. You know, kind of like functions in real world programming. The parameters have to match here. So, you know, I have what, student number first. I have to select student number first, and then the name, you know, Joe Blow, and his GPA. He's a good student, and he'll be a computer science guy. Okay. And let's go ahead and add people in this manner. What have I got here? Well, that's no good. Let me take a look at my students table here. Student number .90. Oh. I told you before last week you guys are smarter than me, and I just proved it. There we go. Generic name, Sally Smith. Alright, she'll be a good student too, and she's going to be an engineer. Okay. And if I were smart, I already admitted I wasn't smart. I would just go ahead and copy the lines and paste it and just modify the info that I want to, that's going to be different from the line above it, but I'm just making things hard for myself here. Hank Hill. Isn't that King from King of the Hill? Hank Hill, right? Since we're going there, let's go ahead and, Zoik Scoob. And Scoob is going to be like a biology guy. Alright. And just so we have more than one, student in a particular department, that'll be good for, problem purposes, so you can really see what's going on and kind of wrap your head around it. Gosh, we want this last student to be. We'll make him the king of rock and roll. What do you say? Alright, and the king is cool. He's got a high GPA too. And high pulls it off. Alright, we'll go ahead and add these. There we go. Went ahead and added 5 of them, right? Alright. So let's go ahead and see our work. I have a sneaky suspicion I know why this happened. Okay, the purpose of the primary key is to keep array unique, right? And the database will enforce this. It will not let you insert more than one row that has the same primary key. So you can only have one primary key in that. If you, let's say, my student number 1, 2, 3, 4, 5, 6, 7, 8, 9, I should only have one of those. It should not allow me to insert a second copy. So I think what happened here, I didn't, for some reason I didn't get my primary key right when I created that table. Let's see here. Aha, that's exactly what happened. All right. Well, I'll tell you what. I will, how do I do this? Let's see, alter table. I can't remember if we've gone over this or not yet. No, I don't think we've gone over the alter table and then the constraints. But this is how you'll add a primary key if you want to after the fact. It should be something like this. Yeah, it should take that. You know what, I'm going to have to actually delete all these rows. I bet you, here, this would be a good lesson. This would be a good one for you. It will not let me add this primary key constraint, because if I do, that table will immediately be in violation of that primary key constraint because I have more than one copy. Let's look at this again. Here, I'll go ahead and control F this here. Student. There we go. All right, so yeah, see, I've got more than one copy, of course, because I must have clicked the little lightning flash up here 3 times, is what I did apparently. I guess I got impatient, or maybe I had too much caffeine and twitchy trigger finger or something like that. But anyway, if I tried this right now, I bet it's going to deny it because it's going to say, hey, you're already in violation of this primary key constraint because you have more than one instance of any particular primary key. So let's try it. This would be a good one for us. What happened? Duplicate entry. Exactly. And it was that first entry that I pointed at was the 1, 2, 3, 4, 5, 6, 7, 8, 9. So, it found that right off the bat. So what I'm going to have to do is, like we talked about last week, delete from students. And as long as I don't put a qualifier there to delete all the data out of the student table, and that's where you have to be careful too. When you delete or update, you always, always, always want your where clause after that, or else guess what? You're deleting all your data, you're updating all your data, whether you want to or not. If you do that, what is it, Homer Simpson? Nope. All right. So let's go ahead and delete from student. And I'll pause you for, let's see, yeah, that's a little, my typical thing. I'll pause you for a second and I'll go ahead and add those rows back so that we don't do, I don't make you sit there for 5 minutes while I type this stuff in again, just to show you basic data entry. You already know how to do that, okay? So I'll pause this for just a moment, come right back. Okay, I'm back. I went ahead and deleted all the data out of that student table. I added the primary key, the constraint for student number, and so now I've put my data entry back in here, so we have our students back here. All right, so I'm going to go ahead and add them, and I will. There we go. Yep. Now, just for kicks and giggles, let's go ahead and try it again now that I have that primary key constraint in there. Ruh-roh. Yeah. So it went ahead and forbid the. Or forbade, if you will. I guess forbade, is that right? That sounds right. The duplicate entry. So, once I have my primary key constraint there, it says you can't add another row that already has, the same, that already has that primary key. All right. So we'll go ahead and do our work. And there they are. Okay. Now let's go ahead and get a count of this. Oh. Alright, so I got 1, 2, 3, 4, 5. This should return 5. Yep, returns 5. Alright, and what else did we have? We had department. We called it DEPT. Indeed. Okay, and there are 4 rows there, so that should give me a count of 4. Sure enough. All right. Now, we're covering joins, and just want to briefly cover this, but, towards the beginning of the book, or at the beginning of the chapter, I guess, the Cartesian product is really the first thing discussed there. So, your result set, that's what we call the rows that you get back, all the information back is called a result set. Your result set can vary in size from 0 up to the Cartesian product. Now, the Cartesian product is going to be the product of the number of rows of each table that you join. So, in other words, in this case, to give you an example, my result set can vary from 0 to 20 entries. Guys, if I go ahead and say, let's say, so, and I'll jump ahead of us a little bit and do a where, but don't worry about that too much. I'll go ahead and do a join, echo join here. Select all from because department code. We know this will never match. I'm just basically saying, get everything from students and departments table. Okay, get all the rows where my student number is equal to the department code. We know that's not going to happen because they're not even the same types of attributes. The data type is different there. And of course, we got 0. So fetched 0 records. Fetched. It's kind of like a dog. I like it. I'm a dog fan. I'm an animal lover in general. So we got 0 rows. All right, and that's not a surprise because we did not expect anything to match. Okay, student number will never be the same as department code here. So those rows really don't have that criteria in column. In common, so nothing's going to be returned. Now on the other end of the spectrum, I could have a Cartesian product. Okay, so I can have from 0 to 20 because I think we said. We had 5, so let's count from students. Yeah, we had 5, and then here in the department table we had 4. 5 times 4 is 20. All right. Voila. So you see what I did here. And in fact, I can pretty much duplicate the same thing, except instead of giving you the number, I can give you the rows. This is how you do a Cartesian product. You can, number one, not specify a where clause at all. Okay? Not specify any condition. Select all from department students. That's going to give me every darn thing. Every possible combination or permutation of them. So there we go. Actually combination, not even permutation. So it's even more than a permutation. All right, so there we go, 20. Okay? That's one way of getting a Cartesian product. Don't specify a where clause. Or I can specify a where clause that will return all rows. Here's a question for you. How would I get an equijoin? Well, let me not go get ahead of ourselves here. Let's not get too far ahead. But anyways, there you go. Select all from department, students will do an equijoin. Now, and actually, let me back up for just a sec. And I think, gosh, is it this chapter? I can't remember, but since we're talking about count, which is a good point to make, okay? When you start getting into 3 or more tables, and when you start getting into big tables, if you go ahead and do a query fearlessly, if you just charge it, and trust me, you will do it once or twice, and it will mess everything up, and you have to start all over from scratch. So you only do it once, but if you don't kind of peek, I think the book even calls it peek, as a matter of fact, that's exactly what he calls it that. But if you don't peek at your data ahead of time, once you start getting into more complicated queries and joins and several tables, you can have a whole heck of a lot of results, and it's unmanageable. So you can use count to peek there to kind of see if you're going down the right road. There 20 is definitely not an unwieldy number, but if this were 2 million, 200,000, 20,000, or heck, even we're using the terminal for output for our Oracle, so even if you had 200, that would be a pretty unwieldy result set there. So you can kind of peek by instead of select, you can change select all, or you can even change your column name to select count, and then you'll get an idea of how big your result set is. And you can say, oh heck no, 35,000, I can't, I'll have to shut down my machine because these results keep scrolling and scrolling and scrolling by the terminal screen, and I can't do anything with this, and then my spool output is, all mucked up at that point. So there you go there. All right. And I kind of jumped ahead there with the join, but I'd like to go back to it and see here. We'll go ahead with the basic. So now, as the PowerPoint discusses, you'll pretty much be joining on primary keys and foreign keys, okay? Because that's what two tables are going to have in common. That's how you link two tables. The foreign key to one of them is the primary key of the other, right? Okay. So I hope you said right. All right. So if we look, let's look one more time. There we go. All right. Here's my primary key, here's my foreign key. My foreign key is major department code, all right? And if I go over to department, I see there's the primary key. Yeah, and I'm sure there's a little graphical I haven't used this GUI too much, but I'm sure there's a graphical interface that will show the relation between the table. Kind of like you can do in, SQL Server, and I think you can do in Access as well. That'll show the relation between the foreign keys and the primary keys. But anyways, you can see it there. This is an easy example. Otherwise, I would trudge through that and dig it out to show here. But anyways, we know that the foreign key of students is department code, which is the primary key of the department table. Okay. So I'll go ahead and do a basic join on this. All right. So now, when we're doing this join, basically what we're asking. Let's think of the most basic one. All right, so we're going to join a foreign key to a primary key. Let's say, all right, we want to know all students and their corresponding department information. In other words, I want all student information and all the information of the department that corresponds to their major. Okay? Now think about this real quick. I'd like you to put me on pause there and think about it, maybe think through the book, do a little self-discovery anyways, because I'd hate to just show you. And kind of ruin the surprise there for you. Actually, it's not a surprise. I'm pretty sure you already have a pretty good idea, but go ahead and put me on pause and come right back. Okay, you ready? All right, so you guessed it, it's going to be a join. All right, now there are a couple different ways to do a join. I'll show you the way I like first. Okay, the most straightforward way to me anyways. All right. Okay, so notice here's our first little difference. Students, comma, department, table 1, comma, table 2, comma, table 3, etc. All right, and then we have our where, so that's our equijoin clause, okay? Well, actually, not yet, it's not. All right, easy enough, right? So basically what this is saying in English is, okay, get me everything from student and everything from department, okay? For those entries whose major department code matches the department code. All right? That makes sense to you? Select everything from students and department where the student's major department code matches the department code. And of course there's going to be one entry for each row, for each student anyway. Because all students have majors, they have to. In fact, it's a foreign key over there, so well, actually, let me look real quick before I say that. Nope, never mind. Well, they don't have to, but anyways, they will. Okay, because we've populated that info for all of them. All right. So yeah, okay, so select all information from these two tables on this matching condition, where your major department code equals the department code. Okay, primary key maps over to foreign key perfectly, right? So let's go ahead and I'll run this without any further ado. I've been blabbing on long enough so you can see it for yourself. So there we go. All right, so we got Hank Hill, okay? He's from what, Arlen, Texas or something like that? And he's an art student. And there's the art department's name and the art department's budget. Okay, so it scanned through, found that I won't bother you with the low-level details there. There are all kinds of optimizer things, and I couldn't possibly give you a full explanation of of how it gets the results within modern, with query optimizing and what have you. We got Scooby-Doo's a biology major, and there's everything. Joe Blow, there's everything about the computer science department, which he's a computer science major, and the same for Sally and Elvis. The King and Sally are both engineering majors. Okay, so there you go. That's your very basic join, just your equal join, foreign key, primary key, two tables. All right. Now, this is also called an inner join. We have inner joins and we have outer joins. Okay, it seems a little less straightforward for me, even internal to myself. I never do this. But I'll go ahead and write it that way to show you that this is your ANSI SQL. ANSI is what? American National Standards Institute, I believe. So here's the same thing written in ANSI SQL. Alright, select all from students, inner, join, first table, department. Well, let me make this a little clearer for you. No, that's correct. Okay, so select all from first table students, inner join department, second table, on, and then I have my match here, my join, my where clause. Okay. So as you can see, it's not as straightforward. When I look at where major department code equals department code, you can almost say the same thing in English, so that's a little more straightforward to me. But this is ANSI SQL. Select all from table 1, inner join table 2, on, and then your where clause, okay, your equality clause. And let's show you that it'll do the same thing. There we go. Yep. Hank, Scooby, Joe, Sally, and Elvis. All right. So that's your ANSI SQL version of the where clause. All right, and I don't remember if I showed you last week, but I don't think so. So we'll go ahead and real quick here. Well, actually, yeah. This is I can kill two birds with one stone here. All right, so table aliases, and access it is a little bit different, but I don't believe this is even covered in the book, so I'm not gonna bog you down with the access detail. Okay, so here's the same thing using table aliases. You can shorten your queries up, and you can make life a little bit easier for yourself here this way. So I'm going to create aliases S and D for student and department. Okay. Over here, next to the table name, immediately after the table name, I have a space, and this is the same syntax in SQL. All right, and then I have the alias that I want to call that table. And same over here. All right. So I have the alias S for students, alias D for department. Okay. So that saves me from typing students and departments, and when you type big long queries, it gets a little bit easier. All right. And it doesn't matter that I define S and D after my references to S and D here. It's okay. It doesn't really view it sequentially. It's not quite like a gosh, I can't remember. It's been so long since I've taken a programming languages course. It's not quite like, it's, what am I looking for? As far as the parsing, it's more like compiled and interpreted, if you will, to put it crudely. All right. So it knows anyways, S and D. It goes ahead and compiles everything. It takes the whole string, it doesn't parse it left to right necessarily. Strictly, so it knows that S and D is this S and D. All right. So select student number, department name from student's department, where student department, major department code equals department code. Okay, because S and D are just handles, if you will, for student and department. So let's go ahead and show you that this works. Indeed. So, another thing I wanted to show you about this. This is, I'm just selecting these two columns. I know you saw this in the book, and you already know this, but I don't think I mentioned it in last week's lesson. So anyways, there you go. So kind of killing two birds with one stone. I'm showing you the table aliases, and also that you can just select certain columns, instead of, as opposed to just a select all. Oops. Excuse me. A select all, which would just select everything. Instead, we just have these two columns returned, because those were what I specified here. I specified student number and department name. Okay. Okay, let's go ahead and add a third table in here. We'll give you a little more advanced complexity because they covered it in the book too. I'm going to add another table. Or can add another table. Okay, on department, they have a budget, so I'll go ahead and add a sponsor table, and the sponsor will be responsible for their budget. It'll help. It's kind of, I guess, what endows them with the money to go ahead and do the research and what have you, their department budget, okay, their departmental budget. So first, yeah, we'll do something like this, all right. Okay, so I'll go ahead and add. This is the foreign key. I didn't create the constraint, but I will. This is the foreign key from the department table that will map over to this. Is going to be the primary key of the agency table that I'm going to create. I just figured I'd create it on the department side first. So I'll go ahead and create some little fictitious agencies, I guess, to go ahead and map. Ford Foundation. Yep, there we go. That'll work. And since they're technical, actually not really. Let's go ahead and assign them to computer science and engineering. Yeah, those will be the Ford Foundation is the sponsor for. Let's see, what do I have? Parsing error there. Let's see. Oh, I don't have an equals there. Told you guys are smarter than me. All right. I'll go ahead and say, Ford Foundation is maybe the computer science and engineering department sponsoring agency, and here's their four character codes. All right, and I'll do the same for. Gosh, what are the rest? Gosh, we got computer science. We got. There we go. We got, gosh, we had biology and art. ABC sponsor went out. And I guess there'll be the biology sponsor went out. Yeah, Department of Biology. The biological sciences, that's nothing more important. All right, and then we'll just say, BCD sponsor, where they'll sponsor the art department. So let's see, that should be all of those, right? Yeah. And here's a good one for you, before I forget. All right, so now, if I go ahead and do a Cartesian product of these three tables, how many results should I get? Think about it. Okay, you got the answer in your head? Gosh, I forgot what I call these things. Department, students. Oh, I haven't created the sponsor agency table yet. I will, then I'll show you. I was getting way ahead of myself. I do that sometimes. And you know what? Speaking of getting ahead of myself, I did not create that foreign key constraint. I will here after this. Okay, so now I'll go ahead and create the sponsoring agency table. All right. We have our code, which is going to be, this primary key is going to be the foreign key in the department table. Okay, that's how I'm going to map. That's how I'm going to get those two tables together. All right. And agency name is just kind of a little friendly name. It's a character string of 140, and I'll go ahead and create it. Okay. Yeah, there we go. And I guess I'll populate the information in there that I started putting into the department table. So I think the Ford Foundation is going to be, well, it doesn't matter. I'll just enter the information in here. And again, here I am making a lot of work for myself, typing all this stuff out when I could be just copying and pasting, but I just don't learn my lesson. I think that was what I called these things. Okay, now, how many results am I going to get from the Cartesian product, huh? Real quick, what's 5 times 4 times 3? You already knew it, didn't you? There we go, 60. Okay. All right, so why did I do that? Well, all right. This brings up a good point. Sometimes you need to jump through hoops to get data. Your data is not always going to be in the same table. As we saw earlier, we discussed it a little bit earlier. When we map from our ER diagrams to actual database tables, we split them up. We do that for a reason. We don't want unnormalized tables because then we're subject to all kinds of anomalies. We have update, delete, insert, and update, delete, and insert anomalies. Okay, so this can corrupt our data, can create inconsistent data in the table. That's why we normalize. That's why it's not good to have all of our data in one single table, which is definitely possible, just not really feasible, and it's not what you do. Okay, so as a result, our data can be fragmented. Sometimes, well, a heck of a lot of time, we have to jump from table to table to get this data. Okay, because not all of it's contained in one table. All right. And sometimes we'll have to jump through intermediary tables to get to other tables. And the book gives examples of this, but I'll show you one right here. So we've got students, which is linked to department through department code, right? Which itself is linked to sponsor agency through agency code. Okay? So there you go. So let's say, okay, here's a perfect example. Let's say I want the student information for any departments, any students that are majoring in departments that are sponsored by the Ford Foundation. Let's say that they want to give them grants. Okay. How am I going to do that? Think about it, try to write it out, and come back in just a sec. All right. I think that's what I call these. Okay, I'll need all three tables, right? Well, you'll see why in just a sec, if you haven't already figured it out. Now let's start on this side so we don't get confused. Okay, so we're starting at student. Okay. Now from student, I'll jump over to department. How do I do that? Equijoin, right? This works. So I'm getting all student information, all right, where the department code and the major department code match. Okay. Okay, and then since I can't jump straight from student, I have no way of relating student and sponsor agency because there's just no data in common. So I kind of have to jump through department. You know, there's a primary key to foreign key, and then the primary key of that table to the next foreign key. So I'm kind of jumping through department table, if you want to think of it that way. All right. And so then I jump from here. Oh, let's say, what did I call this? Sponsor. It's called sponsor agency code in department. Let me take a look at this just a second, make sure it's correct. Bear with me. Yep, that should be right. Okay. So this will give me my student number and student name of all students that are majoring in a particular department, well, that are majoring in any department, and the associated agency code. Well, the associated department's agency code. Okay. Now, I'll tell you what, we'll just make this here so you can kind of wrap your heads around how this works. Go ahead and make it all to start with, okay? So what we're going to see as a result of every single student's going to be here, all right? We are going to see the student's information, we're going to see the department's information, and the sponsor agency's information. So we'll go ahead and execute this right here. Let's see. What do I have wrong? What did I do? Oh, student. That's like the third time I've done that. All right, so there we go. We got Joe Blow, computer science, okay? Now if I come over, since he's computer science, their sponsor agency code is here, as well as engineering, okay, and biological sciences. Why is art not there? That's a good question. Let me. I think I had an artist here, didn't I? Was it Scooby-Doo was art? No, Scooby-Doo was biology. Who's missing? Hank Hill. He's there. Oh, I guess I don't have any. Well, I do have an art student. Currently named Art. Concentration code BCDS. I called it BDCS. Well, how do I change that? There's a good one for you. How do I change that, huh? And this isn't a contradiction in terms. It will take this. This is valid syntax. So what I'm telling it to do, it kind of looks at it this way. Okay, wherever the agency code is BDCS, I'll change it to BCDS. Okay, so it's not going to say, oh wait, I can't change it because it's this. It'll go ahead and take the syntax. Okay, set the code equal to BCDS for this row, and that's what it's going to do. I hope this is going to make a liar out of me. Let's see here. Give me just a sec here. Let me take a look at it. Okay, it looked like actually I had a leading D here. It was spelled like so.
Although I guess I didn't see the little red underline there when the the parser cut the error. So actually it was valid syntax, so it did take. Okay, so let me try this again. That's what we're doing. Oh yeah, I was doing this big long query. Let's see, did I? No, I didn't save it. It figures, dummy. All right. Right, there we go. So here we see everything matching, all rows line up. Okay. Now what did I say? I wanted the forward foundation, right? What did I call sponsor agency? It's called agency code. Yeah, I think it's called agency code and sponsor. I don't want to do a desk on it, I'm pretty sure of that. Alright, so we'll just add that there and we should get all the forward foundation. So there we go, yeah. So we have the three, alright, so I got the three tables. And as long as I have these two criteria here, remember I'm jumping from table 1 to table 2, table 2 to table 3. Okay, so that's two joins, right? Join table 1 and table 2, then join table 2 and table 3. 2 as my intermediate table. So, if you have 5 joins, you're going 5 tables, you're going to have 4 joins. So it's, n minus 1 join. You'll see that again, hint, hint. Okay. And so there you go. All the results line up. Make sure that you're joining on every table on, some criteria there, or else you're going to get a quasi-Cartesian product. You're going to get more results than you want. Okay. Let me think about what else I can show you. Oh, here we go. Outer join. Okay. Sometimes you'll want to see all results if you join 2 tables, let's say. Sometimes you'll want to see all results from one of the tables, whether or not they're included. Like, let's say, wow, this is difficult. I'll tell you what, we'll just go ahead and do it for the sake of doing it for right now anyways. We won't bother you with, burden you with examples. Okay. If you're like me, you need all the room upstairs you can get. If I learn anything else new, I'll forget like my home phone number or something like that, and I don't want to do that. I have a very finite space in my head, so I don't like to bog it down with a lot of garbage, so I won't do that to you. Okay, so here you see, we had inner join, the ANSI-SQL syntax. If you just wanted, let's say, a regular vanilla equid join, you'll do inner join, right? Now, outer join will display all the results from one table, whether or not they match, okay? And then on the other side, you only see the results from the table that matches, all right? So let's say I'll show you left, and it really works in the same way as the right, just we'll go to the difference here in a sec, but it's pretty intuitive. Let's do this. Yeah, this will work. Okay, so I have a left outer join, all right. Remember the syntax, inner, outer, and then the second table, and then on. It's a little bit awkward, I guess, if you will, but it's less intuitive than me. I don't use it, but it's there. You'll see it, so you better know it. All right. Select all from students, left outer join, department on students, major code equals department major department code. Okay, so what we're saying here is, okay, I want everything. Actually, we don't want everything for both tables, but since it's a left outer join, okay, we want everything from students and only the matching results in department where my major department code equals my department code. So basically where the rows line up, and for my computer science department. So basically what that's saying is I want all students, and then on the right-hand side I only want the information for my computer science department. Okay. Yep. All right, so we're showing all of my students. Okay. Because I did a left outer join. Think of it this way. My students is on the left, and my department's over here on the right. So when I do a left outer join, this is all the stuff I'm going to get. And on the right-hand side, I'm just going to have on my where clause. Okay. Now let's change this to right. What do you think I'll get if I could do a right outer join? What is that? Well, what you should have said, okay, since my department's on the right, I'll get everything from department, and I'll only get students over here that are in the computer science department, if I'm not mistaken. Yep. There we go. So I have all of my departments, since they're on the right. Then on the left, I only have the matching row. The matching row is on my computer science department. Voila. Okay, so there's outer joins for you. Demystified. And you can do a full, you know what? Full outer. Ooh, let's see. Bear with me for just a second. I'm going to do a little bit of investigation here. I've never done this before in MySQL. Okay, it's demystified. Full outer doesn't exist in MySQL. I'm not going to bog you down with a workaround to it, but anyways, there is a full outer join, and it will display both sides. And, it won't be a Cartesian product. It'll just display both sides whether or not they match. Okay, so it's just kind of like combining the two tables there side by side. That's all. All right. And let's see, that's all we want to cover. Oh no. We talked about in the book. The Oracle book talks a little bit about column alias. Now that we covered a table alias. This is how you see it in Access, if I'm not mistaken. So there you go. So the column label is now student number there instead of STNO. They can maybe be a little friendlier. In Oracle, it's this. I'm pretty sure MySQL is not going to take that. Oh, will it? Hey, all right. It accepts the Oracle syntax as well. So there you go. I did it both ways. Okay, so see it both ways there. You'll see it either way depending on whether you're Oracle or Access student. All right, that's pretty much everything I wanted to cover this week. Was kind of the essentials. I hope it wasn't too confusing for you. If it is, post in the discussion forum. I'll answer it when I see it, or you can email or call me directly. Okay. All right. I'll see you in the next lecture.